Hello, chemistry students. Welcome to day 3 or the lesson for April 1st, 2020. The last two videos focused on the basic definition of what a wave is, what a medium is, and how it disturbs the medium. Today's lesson, I wanted to focus on how do you identify a wave? For example, what is one wave versus two waves or 10 waves. So to do that, you have to be able to identify certain characteristics of a wave. And that's going to be today's lesson. We're going to focus on several characteristics over the next 4 or 5 days. The first one is how you count waves and what identifies what one wave is versus two waves. So let's start off with regardless of the type of wave you have, they do have some differences. Yes, that's why they're different types of waves. But they also have certain characteristics that are the same. And you can see them regardless of the type of wave. Uh, Now, the waves that we're going to focus on are what we call transverse waves. Transverse waves are the waves that move up and down like this, where they snake like that. The medium moves up, then it moves down. Medium moves in one direction, and then the direction of the wave is the opposite. It's going forward. So you've got that perpendicular. That's perpendicular. I am not flipping the camera off. That is this finger going up. That's the way the medium moves, but the wave is actually moving that way. That is a transverse wave. Transverse waves have crests and troughs, and you've probably heard of crest before. The crest is the highest point of the wave, where the medium's position is at its highest point. Well, what's the opposite of the highest point? Well, that is what we call the trough. You've probably heard the word trough before. For example, pigs typically eat out of a trough where you have essentially a wooden container that's open on top, sits on the ground. You pour all the food in there, the slop. I don't know. I mean, I've never really fed pigs before, but you put slop there, and the kids and they eat from this low type of eating tray. Well, that is the trough, and on the lowest point of the wave, or where the wave's position, the medium's position, is at its lowest, it's called the trough. Now, you can think of the crest and the trough as just opposites of each other. If one is up, the other one is down. If someone were looking at a wave diagram upside down, then you would think that's the crest and that's the trough. What was the crest is now the trough. Well, it's now the trough is now the crest. So it doesn't matter. It's just if one is up, then the other one is the opposite. Call one the crest, call the other one the trough. And you can see that in any kind of transverse wave where you're going to have crests and troughs. So on my screen, you should see this wave. Actually, three waves are here, and the crest is on the top portion, and then the troughs are on the bottom portions there. If I took this wave diagram and flipped it upside down, then the troughs would be the crests, and the crests would be the troughs. It's all about just being opposites. So what I have, you see just one line that's got ups and downs. But how many waves were there? Well, if you were just listening to me a minute ago, you would have heard me say that there are, in fact, three waves present. So, what does one wave look like? Well, to count waves, which is the big theme for this lesson, is you have to look at a starting point. And you can start practically anywhere on that wave, on that line, but start at one point and then trace your finger to where you wind up at that same spot in the wave. That's kind of hard though, because I'm drawing with my fingers, you can't see it. Let's make this easier. To identify one wave, start at a crest and then go through the line, which means you'll go down and you'll go back up to the same point on that crest. You now have one wave. So it's from one point of the crest, one crest to the next corresponding point on the next crest. That would be considered one wave. So you can count it that way. Or if you're not a top person, let's go to the bottom. Let's go to the trough. Start from one trough, trace your way up, then back down to the next corresponding trough on the, then that would, the next spot, that would be considered one wave. So if you do it that way, it's pretty easy to see. Let's go, wrong way, right here. So here is the spot on the crest that I want to start at. I'm going to go down there, and then boom. That is considered to be one wave. Now, for some people, it's kind of hard to see it that way. So maybe start with the trough. Okay, start with the trough and go here all the way down to that. That is the next corresponding spot. That would be considered one wave. But a lot of times when I draw waves, I don't consider this. I don't start here and like, okay, that's one wave. Actually, I like to make it easier. I like to start from the center line. This would be our medium. This represents whatever our wave is traveling through. I'm going to start right here. I look at where this line connects to that line, and I say, all right, that's my starting point. And then I count. One up. Now, for some people, they think that this is one wave right here. That's actually half of the wave. I like to go all the way up and down past the line, go all the way up right there, and I like to consider this to be my one wave. And I always draw my waves this way. So I know then that I can count one wave as being one up, then one down, back to the next corresponding spot. Now, if you actually took some kind of measuring device and you measured that distance from here to here, you would see that that distance is the same as from here to here, or the length of this line would be exactly the same as the length of the line going from here to here. That's something for later. But here is how I know I have three waves. I go one, that's my first wave, that's my second wave, and that's my third wave. There are three waves here. So now let's go to a different screen and let's see, make sure I do this right. I did this video wrong last time and it really screwed me up. I have to record again. There we go. So here I have a wave machine and I can see this green dot right there. So once again, a wave is a disturbance of a medium. It's energy being transferred through. Well, if I watch this dot, I can see that it moves up and down. It's never going forward because waves never move the material or the medium forward. It just disturbs it and it does a back and forth motion. But if I look at this and trace all the way through, I see that this is the next corresponding spot in the wave. So watch my wave's motion right there. This is the next corresponding spot in the wave. Or maybe start from here, go all the way through, right there. This is one wave. I always find it easiest to go through the medium and not look at the crest or the troughs. Start here, trace one wave through. Now, if you want to play with an animation like this, this is on the phet.colorado.edu website. It has a number of different animations that cover physics, chemistry, and biology. I highly recommend you go there and play around with it and see what's happening. But let me stop sharing this screen and let me do this. Yeah, I'm going to talk my way through all this so I don't screw it up. So there are three waves here. 1, 2, 3. All right. So the last thing I need to cover for this video is, well, what is affecting the number of waves that you have? If you look at this picture, you see, and I got to start here because that's where the line starts. I have 1, 2, 3, 4 waves. But if I look at this picture, I have 1, 2, 3 waves. I had to start here because that's where the line starts. So this has 3 waves. This one has 4 waves. What is making this have a different number of waves? Well, it's the distance between the crests or the troughs. So this distance here is bigger than the distance here. And that distance is what we call the wavelength. The wavelength is the distance between 2 consecutive crests or 2 consecutive troughs. And we represent this measurement, this quantity, with the Greek letter lambda. So far, I've taught you several Greek letters: alpha, beta, gamma. We've got delta. You've even seen theta in trigonometry. We covered micro or mu for our metric system. Well, here's the next one, lambda, which looks like a Y doing a handstand, because those are the little arms and those are the feet. So wavelength is the distance between 2 crests and 2 troughs. So if I compare wave A here, this distance is shorter than that distance. And because this is shorter, I'm able to fit more waves on the line versus the other one. So there is a relationship between wavelength and the number of waves that you have. The shorter the wavelength, the more waves you're going to have. So shorter wavelength means higher number of waves. If you have a longer wavelength, it's the opposite. You're going to have a lower amount of waves. So this, once again, is the wavelength represented by the Greek letter lambda. And we measure that distance in meters. Now, some waves have wavelengths that are thousands of meters long. Those are things like your radio waves and your microwaves, where that distance between 2 crests is extreme. But then you've got some waves that have really, 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 really tiny wavelengths. Those are things like visible light, like the colors of the rainbow, X-rays and gamma rays. They have wavelengths that are millions of times smaller than a meter, which we'll talk about later. Now, the last thing about this video is what effect does that have on light? Because we're looking at number of waves and we're looking at wavelength. Well, this does affect the type of light that you have. Typically, waves with really, really big wavelengths, where you have a fewer number of waves, that's things like radio waves and microwaves. But when you have very, very extremely small, tiny wavelengths, this gives you things like gamma rays and X-rays and UV rays. So the wavelength, that distance, is going to affect the type of light that you have. When you kick it over to sound, which is, it uses longitudinal waves, not transverse waves. Well, this actually has an effect on the type of sound that you hear. Now, I am not going to demonstrate how that affects, but it's essentially higher sounds versus lower sounds. Not how loud they are, but the pitch, where you have sounds like ee versus sounds like oh. Wavelength affects that. All right, so that is it for today's lesson. Your assignment is going to be to count the number of waves you see on each wave diagram that will be included with this packet. I hope you guys enjoyed this lesson. I hope I didn't stutter a lot. If you have any questions, you know where to reach me. You can contact me through my Zoom information, which is posted on Facebook. It's going to be posted in emails. This video you can find on YouTube, all the places you can find this information. So I hope you guys have a good night or day, whenever you're watching this, and I will talk to you later.